So thanks again so much for having us today. I'm so sorry that we're not here in person. We were really looking forward to it and the interactions that you get from that, which was what I've been craving for the last 3 years. So this is much harder online, but we're going to try our best to keep our presentation short and keep this as a conversation, even though that's much harder online. So far we've talked about, through this conference, there's been some amazing presentations about our fragile earth and species extinctions. And in this session, we want to focus on another dimensional level of biodiversity, which is whole ecosystems. First, I want to acknowledge the Wurundjeri people of the Kulin Nation, or the custodians of the land that I live on and its ecosystems, and the land that was never ceded. And I want to recognise the importance of Indigenous people across Australia and across the world in sustaining ecosystems and connection to country. That's so important. I don't think we'll introduce ourselves because you've done such a great job of doing that already, Louisa, so thank you. But what we'll talk about today is ecosystems, why they matter, and how we can conceptualise or think about ecosystems being threatened as well as species being threatened. And this has really been a large part of our research for the last decade or so, as Louisa said, particularly with the red list of ecosystems, and we'll talk about this briefly and introduce it, and then hopefully we can start a conversation. Just as a flag to something that's coming up this afternoon, this first photo on this slide here is from the Tiwi Islands, where we do some of our research on ecosystems, on describing and conceptualising ecosystems and mapping them, working with Tiwi people about ideas of ecosystem and healthy country. This afternoon, my colleague Mavis Kerenow is going to present some of the work from that project. Particularly, it's an artwork that speaks to the project and provides us with a framework for doing research together. And I hope you can stay online for that, because I found her work and the way she talks about it just an extraordinary bringing together of art, culture, science and research to help us find a pathway to a more sustainable future. Okay, so we know that nature is essential for human existence and for our quality of life. So ecosystems in particular, and in particular natural ecosystems, play a really critical role in providing food and water and energy and medicines and many other benefits that are essential for people's well-being. They sequester and store carbon, which is critical in mitigating climate change. We heard about that from David Lindemeyer yesterday. And they protect our coastlines from storms and many other things. They also form a foundation for culture, particularly for Indigenous cultures around the world and here in Australia, and a sense of place and wonder. And of course, they're home to plants and animals and fungi and other forms of life that are too numerous to count. Most of these benefits from nature are irreplaceable. So you could build a seawall to protect your coastline from storm surge, but it can't also be a carbon sink or a nursery for fish or a home to extraordinary biodiversity the way that mangroves or seagrass can and do. And we really heard yesterday from David Lindemeyer about some of the wonders of the mountain ash, but also the many benefits that they provide, especially water for the population of Melbourne. Our drinking water comes from that landscape and those forests. But we also know that that nature, that our ecosystems, our biodiversity are being lost. This biodiversity crisis is well documented, and it's not hyperbolic to call it a crisis. I'm not going to dwell on it because we've seen it so well described in the many sessions of this gathering, including Stephen Meacher today talked about the story of the Leadbeater's possum, and you see it all around you. It's also very well documented and summarised in the work by the what we call IPBES, the Intergovernmental Platform on Biodiversity and Ecosystem Services, which is probably the lesser known younger sibling of the IPCC, the Intergovernmental Panel on Climate Change, whose work we know very well. And IPBES does an extraordinary job of bringing together the knowledge that we have, just like the IPCC does. And in fact, these two organisations, these two bodies work together to produce an outstanding, depressing report that looked at the climate change and biodiversity loss together that just came out this year, if you're interested in having a look at that. So what do these reports tell us? If we look at ecosystems, about half the extent of natural ecosystems globally have been lost over the last 200 years or so. 77% of land and 87% of the seas have been modified by the direct impacts of human activities. About a quarter of the species that have been assessed are at risk of extinction, and global biomass of mammals have declined about 80% in my lifetime. And these have been replaced and displaced by people and livestock, which now account for about 95% of all mammal biomass. The drivers of this loss are complex. We have habitat loss from deforestation and changes in land use and sea and water use, direct exploitation from hunting, fishing and forestry, pollution, invasive species, and here's a photo of 2 of our top 10 worst invasive species in Australia, blackberries and foxes together, and of course climate change. And probably land use change is the largest of these on land, but direct exploitation is probably the greatest driver of change in the sea. And this photo here on the left is from Madagascar, where all flat enough or arable enough land is basically converted to rice production. But in recognising and in response to and motivated by this loss and degradation, we're also seeing increasing global policy action to halt and reverse ecosystem loss and degradation, in addition to, and also all this outstanding local action that we've heard so much about in this conference of people coming together for change at local and national scales affecting policy. At a global level, which is where a lot of my work is, we see, for example, the UN Sustainable Development Goals that emerged over the last decade or agreed on by governments around the world as these aspirations for how we want our world to be, and measurable targets and indicators so we can understand how we're progressing towards these aspirations. We also have the Convention on Biological Diversity, which is the world's primary multilateral treaty for nature, which has over 190 parties or countries as signatories, including Australia. And right now we're undergoing negotiations for the next decade of goals and aspirations and targets for trying to shift the dial and really bend the curve to have nature positive outcomes. And this is really, I think, one of the more optimistic, hopefully not in a delusional way optimistic, but positive moves is this shift towards this nature positive movement, which is happening across society. So we're seeing the private sector as well as governments and civil society and individuals embracing this nature positive movement, which is not just about minimising loss, but really trying to reverse loss and see recovery of biodiversity. But to achieve nature positive outcomes, we need to know where to act and how. And this means we need to know where ecosystems are most at risk of being lost, and how and where we can act to halt this loss and reverse it. So traditionally, when we think about biodiversity loss, there's been a lot of focus on threatened species. And you're probably familiar with the IUCN Red List of Threatened Species, which is the global standard for how we measure whether a species is threatened. And you'd be familiar with it because when you go to a zoo, there's normally a sign. I have small kids, so I spent a lot of time at the zoo over the last decade. And there's a little sign at the species that tells you something about that species, but also its status, if it's critically endangered or vulnerable. And these categories tell us about the risk of extinction that a species faces. We also use a red list in global policy, and in Australia's legislation, for example, to list a species as threatened is the same method for listing it or recognising if a species is endangered. So, for example, this beautiful Indri, which is the largest lemur, and it's basically like a 4-year-old or 5-year-old child in a panda suit leaping through the treetops in the forests in Madagascar, these highland forests. So the Indri is critically endangered because of large declines in its population, declines of over 80% over the last 40 years. And this is the reason why it's considered endangered. So it's actually a quantitative rule set. And this is largely due to habitat loss and also hunting. But until recently, we had no comparable way of saying if a whole ecosystem was threatened and evaluating the risks that they face. And so this was something that we wanted to work on, and this has been a central part of my research over the last sort of 15 years. And so rather than just assessing the risk of a single species like the Indri here, we wanted to understand risks to the whole ecosystem upon which both the injury and innumerable other species depend. And so in the injuries case, this is a dense humid forest of the mountains of Madagascar, and that is also threatened due to extensive deforestation. And just and similarly, we can talk about the leadbeater's possum being threatened, critically endangered, and also the ecosystem that it lives in. And Jess will talk a bit more about that shortly. So about sort of 15 years ago, we embarked on developing a new method to assess risk to whole ecosystems, and this is called the Red List of Ecosystems. So we started this in about the mid-2000s, but in earnest really kicked this into place in about 2007, 2008. And this research was really led particularly by Professor David Keith at University of New South Wales, and also as a joint appointment with state government in New South Wales. And he's one of Australia's leading botanists and ecologists, and he's had an amazing impact on this science, which has involved hundreds of scientists and practitioners around the world. So in 2014, our new framework, the Red List of Ecosystem, was adopted as a global standard by IUCN to go with as a sibling product with the Red List of Threatened Species. So IUCN is International Union for Conservation of Nature, and that's the world's largest and oldest environmental organisation. It was founded by the United Nations immediately after World War II in recognition of this growing challenge of biodiversity loss and the loss of nature. So I'm just going to pass over to Jess now to tell us a bit more about the Red List of Ecosystems, what it does, what it is, what it does, and how we can use it in ecosystem management locally, but also globally. So Jess, over to you.
All right, thanks, Emily, and hi, everyone. I'm excited to be here. So what I'm going to do is give you just a little crash course in the Red List of Ecosystems. So what it does and how it can tell us about the health or the status of ecosystems. So as Emily mentioned before, understanding the risks to species really only tells us about part of the story about how nature is changing. And so the aim of the Red List of Ecosystems is to assess risk to ecosystems as a level of biodiversity. And so we need this information if we're going to be able to protect them and then restore them as well. So the process of doing a Red List of Ecosystems assessment really starts with defining what do we mean by a specific ecosystem or ecosystem type. And so we go through a few-step process in this. So firstly, we start by thinking about what are the really key plants and animals and fungi and microbes, what are the key species that are really critical to characterizing and defining that ecosystem. Next, we think about the physical environment, the environmental conditions, because that influences a lot of the structure of the system, but also what animals and plants and species can survive there. Next, we describe after describing the ecosystem, we have to think about its distribution. So then we have to map it. Where does it actually occur in the world? And then lastly, we identify the key threats to the ecosystem. So some might be affected by land clearing. Other ecosystems are really threatened by changes in the fire regimes, or maybe water temperatures due to climate change. And so what we do once we've done this sort of initial description of the ecosystem and its threats, we can use this to estimate the risk that a species will collapse. And what we mean by a collapse, it's sort of the end point for an ecosystem. So when we think about species, we think about them going extinct, where there's no longer any more individuals of that species left around the world or in a certain location. And for ecosystems, what this means is where the system changes to the point that it just can't maintain those defining features anymore. And this can be driven by different threats. So for instance, maybe sea temperatures have just rose so much that the corals have died, and the key feature of these coral reefs no longer persisting. So therefore, it's not really a coral reef anymore. Or a grassland has just become so invaded with weeds that it just really isn't recognizable as that native grassland anymore. And so in those instances, we describe the ecosystem as collapsed. Next slide. So when we think about how to actually go about measuring risks to species, we think about population sizes, so how many individuals of their species is left. But we also think about the distributions or the extent of the area that these different species cover. But for ecosystems, we need to adapt this and think just a little bit differently about it. And so what we do is we look at 5 different criteria. So the first one is a change in the ecosystem's distribution. So is it increasing over time and increasingly taking over more land area or more of the sea? Or is it decreasing and becoming much more restricted? Or maybe in some cases it's remaining stable over time. Next is thinking about the actual size of that distribution. Is it really widely distributed, or does it only occur over a really small area? So ecosystems that are found only in over a small area are inherently more vulnerable to collapsing. So for instance, if you've got an ecosystem that's only present on a single island, all it might take is a single fire or the introduction of a pathogen or an invasive species for that ecosystem to collapse. So the next thing, the third thing we look at is changes to the physical environment, so the environmental conditions or features that really characterize and support that system. So for instance, changes in the water in wetlands or in rivers, ice caps in Antarctica, maybe seawater temperature in coral reefs, that sort of have characteristic levels of these that are really critical to defining and maintaining that system. And if they change, could push the ecosystem towards collapsing. Next, we have changes we sort of measure change in the living parts of the ecosystem, so the species and how they interact and the roles that those species play in an ecosystem. So for instance, we might want to look at coral cover as a really key feature of coral reefs, but we also might look at the fish and the invertebrates that are important in that system as well. And then the last criterion, the fifth one, is it uses models to estimate sort of the likelihood that an ecosystem will collapse in the future. But I won't go into that one because it's a little bit more technical. So it seems like this is a little bit of a theme actually throughout the last 2 days, but I'm going to talk about one example of a red list assessment that was done and how it works. And so here, as you can see, this is a picture of the mountain ash forest, which is found in the Central Highlands of Victoria, which is probably very familiar to you all by now. So for those of you who don't know, this ecosystem is home to these really beautiful, very tall mountain ash trees, as well as many other species, but in particular, it's really characterized by these tree-dependent animals like the greater glider or the leadbeater's possum, which is Victoria's faunal emblem, and very well introduced by Steve in the last presentation with all those beautiful pictures. And he really gave a perfect primer to my talk, so thank you for that. So for those of you who've ever been there or seen these ecosystems, you know that they're really cool and they're really wet. And as Steve just sort of talked about before, the main threats to these ecosystems are really the logging practices and changes to the fire regimes in the system. But they're also quite vulnerable to climate change. So these species require these sort of cool, wet conditions. And in the future, under climate change, these are predicted to potentially change, which might mean that the climate is no longer suitable to actually support these ecosystems where they currently are. So they've got quite a few threats. And as we've already heard about today, so the leadbeater's possum, which is a key species in this ecosystem, is critically endangered. But people also wanted to know about and understand the threat to the whole ecosystem. And so a team led by Emma Burns and David Lindenmayer, who some of you might have, or hopefully went to his talk yesterday, talking about the Great Forest National Park. So them and their team did a red list of ecosystems assessment for this ecosystem. All right, next slide. All right, so firstly, what they did is they looked at the area of the ecosystem, and they found that over the past sort of 50 years and also even up to the past like 250 years, the area of the ecosystem hadn't really changed. So while it is affected by logging, the trees then do grow back. So overall, the area of the ecosystem hadn't really dramatically changed in a way that would shift this ecosystem towards collapse. And so if this was the only measure that we looked at to sort of try and understand the health of this ecosystem, then we'd think that it's in a pretty good state. So in terms of conservation actions that we'd need to do to maintain this ecosystem, it's least concern. But then, next slide. But then what the team did is look at the living parts of the system. And when they did that, they found a really different story. So as we just heard, the leadbeater possum populations have really substantially declined to the point now that they're critically endangered. But the team also found that a critical part of the ecosystem that supports these possums, as well as other species, is rapidly declining in the past. And that's tree hollows. So these forests are really characterized by these large old growth trees that take just such a long time to form these tree cavities that are really important habitat for these tree-dependent species. And so over time, the forests have been depleted of these old trees, and this is predicted to increase in the future if sort of logging practices are maintained, and same with the fire regimes. And so it's these sort of threats that are really driving the ecosystem to change. And so while technically the ecosystem is still there, it still has all of its characteristic features, it still has the trees that really define the area and the sort of extent of the ecosystem. But actually, because of the loss of these tree hollows, the ecosystem is actually quite degraded. And so it's been listed as critically endangered, which means it's got a really high risk of collapsing in the future. And so from these red list assessments, we get this real rich bank of knowledge that tells us about the ecosystem itself. It tells us about the threats to the ecosystem, how it's changed as a result in the past, or in some cases hasn't changed, but also how the ecosystem is predicted to potentially change in the future, potentially under climate change or under other sort of human or other driven threats. And so we can use this information to inform how we manage ecosystems and then hopefully reduce their risk of collapse and shift them back to a recovery trajectory. So in the case of this ecosystem, the assessment did lead to some changes in the logging and burning regimes, but as shown by Steve earlier, there's still quite a lot of work left to do to protect and restore these ecosystems. So as well as informing how we manage the systems, we can also use it to identify priority areas for restoration, as well as to try and work out what are actually the key things in this ecosystem to monitor that really tell us how it's doing and its sort of risk status. All right, next slide. All right, lucky last. So the mountain ash forest, that's just one example of a red list of ecosystems assessment. But so far we have over 4,000 assessments that have been done all around the world and many more on the way, including a lot that are being done in Australia at the moment, which is very exciting and will hopefully be really useful. And so just a quick rundown on this map. So what it shows is in the reddy pinky colours are the sort of terrestrial freshwater assessments. So in the red, it's where all ecosystems in that region have been assessed. The pink is where a subset of ecosystems have been assessed. So maybe you've done all of the forests in an area or all of the grasslands, something like that. And then the blue ones are for the marine assessment. So dark blue is where all marine ecosystems within those regions have been assessed. And then the light blue is where a subset. And then the other ones show where there's sort of preliminary or in progress assessments. And so there's still a bit of the world left to go, but we're making really steady progress, which is really exciting to see. And so these red list of ecosystems assessments, they provide like really valuable information about how ecosystems around the world are changing and the implications for human actions, both positive and negative. And so we can use these to identify the places and the types of ecosystems that are most threatened or degrading the fastest, which is really important if we're going to take action. So the information that we're getting from these assessments is going to be forming the basis of how we measure progress towards these global conservation targets under the Conservation on Biological Diversity that Emily mentioned before. And so we're going to be using these to work out whether we're meeting our targets and whether we are reversing the declines and restoring ecosystems. All right, that's it for me. So I'll pass on to Kate to take a deep dive into the marine world.
Thanks, Jess. Yeah, I'm going to just spend a few minutes talking about why marine ecosystems are a bit different and the kinds of challenges that we're looking at, that we're facing when we look at marine ecosystems and trying to understand what the risks are of collapse. And then also a little bit about what we're doing to try and fill those gaps and meet those challenges. So marine ecosystems obviously support a huge range of biodiversity as well, and they are of big cultural importance in a lot of societies that have been living along the coasts and with the sea for many millennia. They also provide us with a lot of food through fishing and aquaculture, and similarly a lot of livelihoods for communities as well. And they play a big role in climate regulation and now also providing renewable energy into the future. So they're very important for a lot of reasons. And they're threatened by things similar to on land, things like pollution, overexploitation, so overfishing, or bycatch of species that are not intended to be caught in the first place. And then invasive species, which are spread around much more easily now that we have international shipping and the way that people move around the world these days. And then climate change is obviously a really big one as well. Along with habitat as coast modified and things like dredging of seabeds and trawling for fishing. So we are still keeping a very close eye on them. Next slide, please, Emily. So Jess has been explaining that part of understanding what an ecosystem is defining its key characteristics. And just to go back to the favorite mountain ash example, in those forests, you would identify them by saying it's a temperate forest, so you can look at the climate conditions, and it's distinguished by a single story of tree species, mostly mountain ash. And then the specific species you would find there, like just described, the leadbeater's possum and the gliders. Like in many terrestrial systems, those key features, the trees, are fixed in position. You can observe them. So you can either use satellite imagery, or you can go onto that land and walk around and map visible parts of the ecosystem and go and see what's going on like that. But so in this picture, it's an example of land cover being mapped from satellite imagery and producing a distribution map telling you which ecosystems or what's happening in different parts. Next slide, please. But in marine ecosystems is a bit more of a challenge because you can still define them with the key features, and that would be things like water temperature or currents, and again, the typical species that are found there. But the problem is that often those features are mobile and they are quite variable as well. So it might be changing on an annual basis, seasonally, or it might even be over the course of the day. The features would change quite dramatically. And that makes it a bit harder to identify where the boundaries are. And people have mapped out marine ecosystems. So this map is showing where the large marine ecosystems of the world are. But when it comes to understanding how healthy those ecosystems are or how close they might be to collapse, it's a bit more difficult. If you, like Jess was describing, if you're assuming that a system has collapsed when a key feature is not there anymore or is changed beyond what it needs to be functional in the system, but that feature is by its nature really mobile, and sometimes it's not there because as a part of natural variability, it becomes quite challenging to assess risk of collapse. So just going back to the map that Jess was showing earlier, there've been a lot of these red lists of ecosystems assessment, but there's less than 10% of them are in marine systems for the reasons that I've described. And the ones that have been assessed, they tend to be the ones that are most accessible. So either it's close to land, so you can actually visit the system or see the system from the shore, or it's easily visible from the air. So that's going to be things that have fixed features like kelp forests or coral reefs or coastal systems. So just on to the next slide, please. Once you can see the system from the air, this is an example of a coral reef system. You can do things like map the extent from aerial photos. You can go to the reef, you can do dive surveys and see what creatures are there and how things have changed. And that makes it a bit easier to start understanding what that state of that system is. But there are still quite a lot of question marks that we are dealing with when it comes to defining marine ecosystems. And that's particularly difficult when you're coming to these pelagic or offshore systems where there's no fixed boundary. So one of the tools, I'm just going to talk briefly about something that the Red List of Ecosystems team has been working on, is a tool called the Global Ecosystem Typology. And what that is a way for us to start dealing with some of these unknowns and generalize in a really meaningful way. So there's a website, and we'll put a link in the chat at some stage, but the idea is that, just the next slide, please. You can divide each type of ecosystem types around the world. You can divide them into realms. So you've got terrestrial systems, marine systems, freshwater, and then you divide those into finer and finer detail based on their similar features and drivers. So you end up with a set of systems. So for example, the mountain ash is a temperate forest. And then you can say, well, there's a lot of other temperate forests. They tend to have these kind of features. That means if we're dealing with a system where we don't know a lot, we can base our assumptions on systems that are much better known. And it's a way of we're just starting to grapple with the knowledge gaps, because unfortunately we need to be making decisions about a lot of these systems already, even though we might not necessarily have perfect data. So this is a really good way to start moving forward. And you can go and explore this website yourself. There's ways to select countries, or you can draw a little box around the area that you care about, and it will tell you what kinds of ecosystems are there, and there's a little map of where those ecosystems are found. And it's a really great resource for any kind of work on understanding ecosystem change or planning, things like that. Yeah, so like Emily and Jess have both said, a lot of our work has been around trying to understand what defines an ecosystem, how to understand what change looks like, and then using that information to inform management decisions. So what do you need to do in that case? If you want a different outcome, what are the levers that you can pull on? And I'll pass it back to Emily with that. Thanks.
Thanks so much, Kate, for that, and for also introducing us to the global ecosystem typology. I'm going to put a link to that and some other things in the chat shortly, so you can explore it yourself. But I just love reading, like traveling through the website of the global ecosystem typology and exploring the ecosystems of the world. And especially during all these lockdowns, for me, it was like a way to travel and do as best I could from my home in Brunswick to immerse myself in nature. So I guess the key take-home message that I hope that you can take away from this is that ecosystems sustain us and the plants and the animals that we love. When we assess an ecosystem using the Red List of Ecosystems method, we can take undertake a diagnosis, much like when a doctor sees a patient and they're assessing a patient's health. And we can examine the ecosystem health in different ways and identify different problems or symptoms like climate change impacts, overfishing, and try and understand those symptoms and treat them through management and policy actions. And in this way, we can work together to try and sustain these ecosystems that we love. So one of the more positive things that I think we can take is that we now have a much greater array of tools to understand which ecosystems are threatened and why, and what we can do about it. And we're also starting to see, I think, real momentum for change across sectors to reverse the loss of nature. And that includes, I think, a much more positive feeling for many of us with the change of government, that there seems to be a much more greater interest, and I think that some of our other speakers have talked about that in terms of like change of the Minister for the Environment, for example, who seems to be a little bit more interested in perhaps taking some action. And I think this movement for nature positive action across sectors has really given me some hope for the future, as well as seeing the way that the next generation cares so strongly for the environment and is really motivated for change. So thanks again for the opportunity to talk with you all today. I'm really sorry that we couldn't be there. We would love to open this up to discussions and a conversation. And what I'll do is stop sharing now, if I can do that, and pop some links in the chats for you to explore. I haven't been able to see the chat, so sorry up to this point. Here is a whole bunch of links for you to explore, including a course that we developed. If you want to do a free online course to learn more about the Red List of Ecosystems, you can log on, do that for free, and it takes probably a couple of days or a few evenings with some nice videos and things like that, as well as some text, so you can learn more about what we do.
And do you roll that out in schools?
We don't. You could use it. We have school kids doing it because it's a really participatory online course. If you can, where we really, it's like a series of blogs and videos, and we give tasks for the students to do, and so they tell us about, you know, why they're there, and we have like school children or more high school students doing the course, right through to professionals. Just interested people. It's aimed to be as broad as possible, and different people are going to get very different things from it. But please do, the link in there is a Future Learn course.
I think Linda Williams wanted to ask a question. Are you there, Linda?
Yes, I didn't want to butt in too early. Hi, thank you for that great presentation. I'll turn my camera on briefly. Yeah, I agree with you entirely, Emily, that it's no exaggeration to call this a biodiversity crisis. And you mentioned you've, in a fairly upbeat way, management and policy action as a solution, and indeed they are solutions. But it seems to me that there's a need, and I don't know if you'd agree with this, but for much broader public communication of I mean, I think we'd all agree there's a need for greater public communication around climate change. One thing is communication, another is action. And there does seem to be a shift, as I think you pointed out, in Australia around awareness of climate change. I think even though people know the fact, a lot of people know that Australia is very high, in fact, the highest in some areas of extinction rates. There's still, I get the sense that the penny hasn't entirely dropped in terms of the climate crisis has dropped. The biodiversity penny doesn't seem to have quite dropped, although some of those images of the bushfires and so on, I think changed that. But sorry to ramble on, but my basic question was, do you think there's a role for greater collaboration between the arts, by which I include the humanities and social science, and the sciences, in trying to form the kind of research that will act to shift public policy? So it's a big question, but it was one I was sort of starting to touch on a little bit yesterday. Just wondered how you'd respond to that.
Yeah, it's a great question. Absolutely. I think scientists are a peculiar breed. We like facts and we like to act on facts, and we assume that everybody else is the same as us, which they aren't. We're self-selecting. And we sort of, there's this tendency among scientists, like if we just put the information out there, everyone will get it and change. And that's obviously not the case. I think there's a huge role in the social sciences to understand the motivations and how we can change. And the only way we're going to get change is by proper transdisciplinary research. And by transdisciplinary, it means across disciplines, but also across sectors. So where you're working with stakeholders and decision makers, not just academics in their ivory tower, or rather their, now it's their home office and Zoom rather than ivory tower. But there's going to be a huge role for collaboration. It's the only way we will get things done. And similarly, we can't put it back onto individuals to change their behaviour. We have to have major change in structural change in the system, but also we as individuals need to work as well. So I think that requires cross-sectoral collaboration to have the transformative change that we need across our economy and society to reverse the impacts we're having on nature.
Well, thanks for that. I agree with it, what you said, and if I may, I'll follow up with you later, beyond this, in relation to work we're doing in Aegis. But just briefly, if I don't want to talk for too long, but I know scientists have a very particular way of doing, after conversations with many of them, and I think artists too have their own particular take on things, and certainly don't want to merely illustrate the findings of science. So getting those actually more meaningful interactions, the devil's often in the detail. And I think there's been a bit of a tendency in trying to set up art-science collaborations, for example, for it just to end up in the too hard basket. There are, of course, great exceptions, but it requires a different kind of mindset. And I think the word crisis is key in that. It's it necessitates looking at new methodologies and so on. Anyway, I've spoken for long enough. Thank you. I'll be in touch.
Great. And look, I was just going to add as an addendum to that is Mavis Kerenau will be talking about a project that we have at the moment with the Tiwi Islands. I mentioned it earlier at the start of our presentation, and that is a transdisciplinary project where we're co-creating research and knowledge to support Tiwi decisions on Tiwi land, and in that project we're working co-developing knowledge with Tiwi stakeholders, scientists, and social scientists, and it's such a steep learning curve. Like artists have to throw aside so many of the things that I've been taught and the assumptions as a scientist, and just listen, and that's not. It's hard to do. It's hard work. But I think that's the only way that we can move forward, even though it makes your head hurt and your heart hurt. But it is the only way that we can do this. And you do have to really push yourself into that. It's challenging to have a lot of your assumptions challenged as well.
Yeah, thank you.
I think I might just add a little bit to that. Like, I really agree. I think that art has such a huge role to play in this, because for anything to change, like people need to care, right? Like, we can give them all the facts, but if they don't really care and they don't feel it, then nothing's really going to change. And we've sort of seen that a lot with past governments and whatnot. But I think art has a way of really making people feel and making people care, and showing things in a way that maybe just reading an article might not quite click, and they might not engage with it or relate to it in a way, but art can really do that. And I mean art in different forms, whether it's storytelling or visual arts or whatever it is. Obviously lots of different types of arts, and I think that it's just one other avenue to really get people to connect and to care, and then to start thinking about this. Because I know that when I've been to art exhibitions, sometimes things just really stick with you and you keep thinking about it, and just really can have quite a big effect. So I think the arts is just so important for that. Yeah.
Thanks, Jess. I think that's really spot on.
I just wanted to ask you, there's a few questions coming in now, but I just wanted to ask, in the work that you do, you're also optimistic, come across as quite optimistic, but you're on the front line studying these ecosystems that are on the verge of collapse. And, I was talking yesterday about how Donna Haraway says, we have a tendency to oscillate between hope and despair. And I just, how do you stay with the trouble, I suppose, doing the work that you're doing?
Kate, did you want to have a go at that? Anyone volunteer to go first? I'm optimistic only because that's the only way you can be. Or you just you don't want to spend too much time in despair in that oscillation. Kate, did you want to add anything?
I think it's tough. I think if you're involved in this topic from any angle, you're going to go back and forth. Probably some days you might need a bit of help to be optimistic. And I do think that, like Jess was saying, that's a big space where the arts can support people when the facts are just too much, to try and bring in some of the more, I don't know, sort of supportive of your heart instead of your head elements. I think for me it's really important to sometimes just focus on the things that we are actually doing and not always the big picture, because that can be really hard. But if you just remind yourself of the things that are actually moving forwards, we are making progress. Obviously the big picture can be quite difficult to look at all at once, but we all doing the bits that we can, and I think that's really important to just remind ourselves of.
One researcher I heard talk about it in terms of keeping a clear line of sight of what you're doing and then the impacts you want to have. And I think if you can think of that in different levels, like Kate was saying, like seeing where you are having a positive impact. So it might be, pulling out weeds in your local patch of bush, or it might be, seeing a government move forward and apply some of the policy recommendations that your science has produced, and then as a result of that, a new national park is formed. And so it can happen on so many different levels. It could be working at a local school and seeing children hear about a plant or an animal for the first time, or going out into the bush. And actually, I really recommend, one of the things I put a link in is this to the kelp keeper, and it's this colleague of ours in South Africa called Luis Odunga, and he talks about the first time he went snorkeling in kelp forests, and that he just wanted to work on that for the rest of his life after that. And so if that would, the person who took him out on his first snorkel has had this flow-on impact. So if you can inspire people as well, I think that is another sphere of impact that you can have, and you can see how that's building to a bigger picture. And I think that's how you can keep your optimism, potentially. I was actually, one thing I was interested to know is one of the ways that we connect with places, ecosystems, is thinking about our favourite natural places. And I'm interested to know, amongst the audience, where their special place is, what their favourite ecosystem is. I've got mine in the background here, which is like Banksia coastal forests. I just love those because that's my happy place. And so even if you just want to pop in the chat just to give a sense of where their sense of home is and sense of place is, I'd love to hear that. I think that's always a really strong connecting force.
I live in some of the last surviving remnants of the reed gum forests and the open woodlands. So that's definitely my place. And it's we've got trees on our property that are about 600 years old. We get the yam daisies pop up, as well as lots of native orchids and everything here, and feel very blessed and fortunate to live on this property. Somehow survived, because we are surrounded by agricultural fields. So yeah, lucky to have this place here. How about you, Melanie?
I was just thinking about that actually, because in South Gippsland, there in the Strzelecki's, there are some nice pockets of bush, but otherwise a lot of it has been cleared. On our particular property, we've got a couple of really big old blue gums, but then reforested trees that we've been working on over the past 15 years. And I do love now that's all getting an understory, and seeing the animals and the eastern grey kangaroos and all of the fauna and avian life coming back to that forest is really special. But funnily enough, I also really, really love the desert in Central Australia. And that's something that I don't know a lot about in regards to climate change and effect. I know a lot of the hopping mice and things are endangered or extinct. But yeah, I'm a bit of both.
One of the things we do in the course, and I just put the link to this free open online course that we developed on there, is at the beginning we asked people to pick an ecosystem type that they either that they love or that they would like to know more about, and they start effectively starting the assessment process for that ecosystem. So we go through and we ask them what describe that ecosystem, where is it, put some photos up, and then think a bit more deeply about what are the characteristic features of that ecosystem, and then is the process that Jess described. It's really about creating that link between this place that you love and this ecosystem that you love, or ecosystem type, because we're not just talking about places, we're talking about the whole of that ecosystem type, and then why it's threatened and what we can do about it. And I think that that's been a good way we've found for getting the students to link in with that.
With identifying a sense of place.
Yeah.
As well. Yeah. Rachel Simon's just commented that they're doing seed saving programs in the Gippsland red gum grassy woodlands. So are you guys involved with much of those sorts of programs in terms of, this ecosystems at risk? What measures do we put in place? We might have to go out and save seeds, or?
Yeah, we're a little bit more at the remove process, like the policy processes, rather than actually doing stuff, I'm afraid. Jess is now doing a lot more research on recovery. And this is, I don't know if you want to say anything more about that, Jess, and how we measure it.
Yeah, sure. I've been doing a little bit of work over the past probably about 2 years. Thinking about how we can restore ecosystems and what kind of management actions we should put in place, which is a really nice complement to the work on the red list of ecosystems I do, which is sort of identifying how at-risk ecosystems are. It's kind of like the what do we do about it? I've been doing a lot of work up in the alpine regions, particularly in the peatlands up there, the sphagnum peatlands, or bogs as some people might know, which has been really cool. And it's been really great to engage a little bit more in that project with sort of land managers and stakeholders and the people who actually on the ground manage these systems. And so we've done a lot of work in talking to them about their experiences in what kind of management has been effective for restoring ecosystems, those peatland ecosystems, as well as sort of working with them to work out what are the key priorities for future research to improve how we can manage those systems. So what are the knowledge gaps that we really need to know to make it sort of more effective at managing those systems. So that's been really cool.
I guess cities are ecosystems too, of a type. And that's where most of us live. I mean, there are these wonderful places that everyone's talking about, but there are also a range of species that exist in cities, not just people. So do you have much to do with that?
I was speaking to a scientist last year about this, and he said, because he's an ecologist, and he said you might see the collapse of one ecosystem, but what comes in is another ecosystem. There's still life happening afterwards. Do you have thoughts?
Yeah, and often so you see collapse of an ecosystem, the new ecosystem emerges, and that's really important for biodiversity still. And it might have many of the same features as the original ecosystem or different ones, and they can be really valuable for people and for biodiversity. There's been a bit of research showing how these tiny pockets of remnant ecosystems that are left in and around cities can be really critical for conservation. Partly because that's all that's left, but also people make cities in places that are good to live. So they have water and a good climate and resources. It's exactly why biodiversity is there as well. So they're often biodiversity hotspots. So there's a lot of biodiversity that is a key part of the cities that we live in. There's been a lot of work on ecosystem accounting, which is another way of measuring change in ecosystems. It's more focused on anthropogenic ecosystems like cities and farmlands and the benefits they bring to people. And they've been thinking a lot about how we measure biodiversity value, but also different values of urban ecosystems to people, like greenness and not just for things like temperature regulation in cities, which is really important, but also all this research that shows that going into more natural areas has really beneficial outcomes for health. So, you know, heart pressure, depression, anxiety, and a whole lot of medical and psychological challenges that we face are helped by being in nature. To the point that I think that doctors in Canada can prescribe national parks membership to help you recover. And I think that would be great to see.
There's a fair bit of work being done on that area at RMIT with its urban focus as well. Yeah,
absolutely. Sarah Beckersey and her team do fantastic conservation work in urban ecosystems, as well as others at Melbourne Uni as well do that, like Kirsten Paris and others that do fantastic work on urban ecology.
Yeah.
That was just wonderful. Thank you so much to the three of you for sharing what you do and sharing all those links. I know that I'm certainly going to do that short online course to better equip myself with this knowledge. There's a lovely comment in here from Rachel Steinman who says, a Maori woman offered to me to embrace being a custodian. Similarly to Indigenous elders have always invited students into the schools and myself to take on this connection and relationship. I think that that's might be a lovely way to sum up the conversation in terms of our own personal responsibility to start thinking of ourselves as custodians, which I really do think the work that you guys are doing is in line with that. So thank you, everyone.